So we have tried to improve the exponential smoothing forecasts, but actually we've made a big mistake. Okay, what is that mistake? Well, we shouldn't have used exponential smoothing to begin with. Why? Because exponential smoothing is only appropriate when there's no seasonality and there's no trend in the data. So we used exponential smoothing for a data set, for a time series, which has seasonality and trend at the same time. So what is the solution? What should we have done to begin with? Well, we have two choices. So we can either change the time series, or we can change the forecast method. What do I mean by that? So we can keep the time series as is, and we can use a different forecast method which is appropriate for seasonal and seasonal time series with trends. Or we can remove seasonality, we can remove trend from the time series and then apply exponential smoothing. Without seasonality, without trend, exponential smoothing should be appropriate for the adjusted data set. Okay, so in this video I'm going to show you how to remove trend and seasonality from the data set. Okay, so for that let's take our actual time series and copy it to a different part of the worksheet. Okay, so now we had these two screens. To close them, to go back to a single screen, I come here, the arrow changes to two headed arrows, and then click and drag it all the way up here. So now I'm just looking at one place in the worksheet. Okay, so this was my data. I click and drag here to select the data. Okay, copy, scroll down here. I'm just want to scroll really past everything. So I'm going to paste. Okay, so I'm just gonna paste. Control V. Okay, so these are my dates. These are my passenger numbers. So how do I remove the seasonality from the data? Okay, so to do that, I take, so this, let's say this is January 06, okay, and this is January 07. Okay, so I subtract January 06 from January 07 to remove seasonality. Okay, so deseasonalized. Okay, so this time series will be deseasonalized. So I'm just going to say equals. Okay, this is January 07 minus January 06. Okay, this is my deseasonalized data, and then I double click over here. Okay. So this is my deseasonalized data, and then I need to remove trend. Okay, so the trended. Okay, how do I detrend a data set or time series? I subtract the previous observation from each observation. So here I come to the second observation and subtract the previous one. Okay, so equals this minus this. Okay, and I click here, come over here, and then double click. Now this is the seasonalized, this is the trended. Okay, so I start with a seasonal time series with trend. I take out seasonality. I should still have trend here. And then I take out the trend. What remains should be pure error, pure randomness. Okay, let's look if this is actually true. So let's draw a line graph. Okay, so I click here, drag over here, all the way to the bottom. Okay, insert line graph, click here. Okay, so the blue line is the seasonal line. Okay, you see it's still there. Okay, now the red line is the seasonalized. It still has trend. How do I know? As you can look here, there is an upward trend, slight upward trend here. Okay, and the green line is completely the seasonalized and the trended. Okay, to see this a little bit better, I want to remove this. Okay, how do I do that? An easy way is, so I have these three series and I want to remove this. An easy way to do this is come here. You see this oblique two-headed arrow, click and drag. So now I have two time series remaining. Okay, so the red one is the seasonalized and the trended. The blue one is the seasonalized, but it has a trend, as you can see, it's going up. Okay, so now what I need to use is my actual data series is this red data series. Okay, time series. Okay, so how do I do that? I just remove the blue one, come over here, click and drag. Okay, so I simply have this deseasonalized, detrended data set. Okay, so once I do that, I can apply the seasonal. I can apply the exponential smoothing, and I can also apply the linear regression. Okay, so let's do that. So I'm going to use these numbers. Okay, I'm going to use these numbers, and I'm going to say, okay, exponential smoothing forecasts. Okay, so let me write down alpha here. Let's say 0.5. You know, we can change alpha later on. So here I have error. For simplicity, I just say, okay, for the first period, let's say this was my forecast. Error equals, this is the actual minus the forecast. Okay, and then what I'll do is I'm just going to copy this forecast and error down. Okay, so equals previous forecast plus alpha times the error. Enter. Okay, and when I copy this down, I don't want the alpha moving, so I click and select this. Okay, and I press F4. Okay, enter. I click down here. Click down here. Okay. So so these are my exponential smoothing forecasts. These are my errors. Let me select these. Oops. And then here, this little arrow here gives you a lot of formatting options. So what I can do is I can select the number, and I want 0 decimal places. Okay, so let me do that. 0 decimal places, and I want 1,000 separator. Okay, so this is what I want. Okay, so let's look at the exponential smoothing forecast. Okay, to add, I right click here. Okay, and then I click select data. Okay, and I want the trended here, and then I want to add exponential smoothing here. This is a serious name. The values will be these. Okay, and I click OK. Okay. So as you can see, there's some discrepancy here. Okay, and where does the discrepancy come from? The discrepancy comes from these empty cells. Okay, so what I must do is click on the blue line. Okay, see the blue border includes these cells too. So I'm gonna come down here. Okay, and I'm gonna eliminate those and enter. Okay. So now I have the red line and blue line overlapping in terms of these dates here, and I don't have the dates. Let me put the dates in. Select data, edit. So where do the dates begin? I'm not going to begin here. The dates begin here. Okay, February 07 through October 12. Okay. So as you can see, this axis is right in the middle of the graph. So let's move the axis down here. Okay, down here. How do I do that? I do that by right-clicking on this axis, format axis. Okay, so the vertical axis. Okay, I selected the wrong axis. We need to select this axis. Okay, now the horizontal axis crosses this vertical axis. Let's do minus 10,000. Minus 10,000. Okay. So is this better? We have the seasonalized. We have the trended. Is this any better? Okay. Let's calculate the forecast quality metrics. So I have the error. I need absolute error. I need absolute percentage error. Okay, how do I do that? Equals absolute error ABS parenthesis the actual error close parenthesis enter here. This will be squared error. Okay, this is absolute percentage error. So and then what I have is squared error equals this error times this error, not that error, this error. Okay, equals that absolute percentage error equals absolute error divided by here. This is the seasonalized, the trended time series that I'm using as the basis of my forecast. This is the actual, this is the forecast. Okay, enter. Okay, so to format, I click these two. So Click here, shift right arrow, shift control down arrow, number. I want 0 decimal places and a separator. This is what I want. Click here, control shift down key, down arrow. I want percentage, and I want 2 decimal places. Okay. So are these any good, or are they any better than the actual data set? So this is my error. So let me go down to calculate the mean forecast error, average, open parenthesis, up arrow, hold down shift and control, up arrow, hold down shift, come down once and twice, and enter. Okay, and then I copy these over here. Here's a problem. Format painter. Okay, minus 88%. Okay, so here's my exponential smoothing mean forecast error with deseasonalized and detrended data. Okay, mean absolute deviation. Okay, mean squared error. Okay, mean absolute percentage error. So these are all for the exponential smoothing forecasts generated with deseasonalized and detrended time series. Okay, are they any better? Let's look at for example, at the mean forecast error, minus 169. Okay, so let's say or up here it was 400. So we used to be under forecasting, now we're over forecasting. Now we were off by 11%. Okay, what percent are we off now? We're almost 89% off. Okay, so we can play with the alpha here as well. Okay, so I want you to do the same thing that you did for alpha as before. So if you remember, we have tried different values of alpha, and we have tried to pick the best alpha value. Okay, in this case, I want you to do the same thing with the deseasonalized and detrended data. Okay, for let's say start with 0.5, try 0.6, 0.8, 0.7, 0.8, or maybe go to 0.4, and try to find out the best alpha for the deseasonalized and detrended data series. Okay.